I'm just showing you heat pump in the winter. Don't say I never did anything for you. In this case, it's a Senville 24,000 BTU Hyper-Heat 2-ton. It's colder than 30 below right now. This thing's been running all night with no help from anything else, and it's keeping our bungalow at 22 degrees inside. So for folks that say these things don't work in cold weather, it's the prairies. There's been a cold snap on. It's been like 29, minus 29, minus 30. It runs a defrost cycle every once in a while, and it runs it quite often now. The fins in the back get a little bit frosted up, as you can see now. So inside the house was 22 degrees. That's the middle number. The bottom number is the sunroom. There's a sensor in the sunroom. It shows minus 26. It's a little warmer than the outside temperature. Just waiting for another reading on this thing to get the outside temperature. This is a regular bungalow. It's about 1,100 square feet. This one's really super well insulated, so I was able to use a 24,000 BTU or 2-ton. If it wasn't really super insulated, I'd go up one size. Use a 36,000 BTU 3-ton, which is kind of a stacked unit with 2 fans, and it's twice as tall. You can hear the defrost cycle now. It's defrosting the frost that was on the back of the heat pump. And so it running backwards though. I always thought it would, but I guess it doesn't. It's just heat being generated. You can actually see it melting in real time here. So the fan's not running during this process. Our temperature gauge sadly is not going to show you the real outside temperature, because in this particular case it just thinks it's alarmingly cold, which it is. This is the inside half of the centrally ducted heat pump. So if your heat pump does shut down, and that's supposed to happen around minus 35 Celsius, if the heat pump itself is running, then there's a inside section. It looks just like an electric furnace basically, and inside here there are what they call heat strips, and the heat strips take over to keep your house warm. It's a backup heat source for when it's minus 35 or colder. This inside unit replaced a natural gas furnace in my case. It was about the same size. In fact, I used the bottom of the old natural gas furnace as a base to set this heat pump on, this inside air handler unit. You can hear it right now just switched off. It's gonna do its thing. Again, the inside temperature of this house has been set to 22 Celsius. It's been 30 below every night. Really haven't had to use these heat strips, although honestly I'm only really doing this because I want to see if the heat pump can do this right down to 30 below, and it definitely can. Normally I'd probably be using the heat strips instead of the heat pump just to lessen the load on the mechanicals of the heat pump. One thing they don't tell you about switching from natural gas to a heat pump is that your insurance costs probably are going to go down. Mine went down by about $200 a year because you're not piping a poisonous explosive gas into your house. You don't really need a carbon monoxide detector anymore, because if you're not using the natural gas for anything else, you can get them to unhook the natural gas from your house. And there's a hookup fee just to have natural gas hooked up to your house. Here it's about 15 bucks a month. So that's, $180 a year also. So basically you're losing in my case, $380 a year of expenses just to have natural gas in your house. If I were to change one thing about this installation, I would have made it more than 6 inches off the ground. Snow is not a problem, as you can see, but ice from the defrost cycle is a thing. So what I'm describing here is a cold climate air source heat pump. I've had quotes before I put this one in from guys that were trying to sell regular heat pumps that basically start switching over at -8 Celsius, which wouldn't really be very helpful in this kind of climate. So if you're going to do it, get a cold climate heat pump. Ground source is great, but they're very expensive. But my point of this is that an air source heat pump that's designed for a cold climate is capable of doing what we're doing here. Also, I sourced this heat pump and bought it separately and installed it with the help of a professional independent local installer who wasn't just trying to sell me something. He just came in basically and did some of the work so I could retain my warranty, and I did what I could on the project, and so it's a doable thing, and they work. That's my point. If it turns out it doesn't work in 10 years, 15 years, if I'm still around, I'll repost. Have a great day.